In this video, we will be exploring the different work groups within the O-RAN specification. The O-RAN specification work is divided into several technical work groups, each covering a specific part of the O-RAN architecture. All of these work groups are open to all members and contributors, so that they could join the discussions, brainstorm, debate, and finalize the O-RAN specifications into their respective areas. Let's dive in and take a closer look. Let's start with the heart of O-RAN by beginning with its comprehensive architecture diagram. At first glance, the multitude of components and interfaces in the O-RAN system might appear overwhelming. However, the brilliance of the O-RAN Alliance is in its systematic approach to standardizing these elements. Each component and interface undergoes a lot of detailings. To manage this expansive task, O-RAN has delegated specification responsibilities to 11 distinct work groups. These groups are sequentially named, starting from Work Group 1 and progressing up to Work Group 11. Every individual work group focuses on specific areas, delving deep to draft detailed specifications. O-RAN adopt an agile methodology, where each specification becomes a platform for robust discussions and constructive debates. These dialogues involve experts and professionals from diverse companies worldwide, ensuring a rich confluence of ideas and expertise. And, thus, these specifications produced by these working groups becomes a reference for all the telecom operators and vendors in the ecosystem. So far, we have understood that each work group is responsible for creating specifications for some respective area of O-RAN architecture. Now, let's understand in details about each of the work group. We will start with Work Group 1. Work Group 1 has the overall responsibility for the O-RAN architecture and use cases. It is responsible for identification of key O-RAN use cases, deployment scenarios, and development of the overall O-RAN architecture. Work Group 1 has 3 task groups under it. Architecture Task Group, which takes care of specifying the overall O-RAN architecture, high-level description of the O-RAN functions, and the associated interfaces. Network Slicing Task Group, which takes care of defining the network slicing related use cases, and alignment with other work groups. Last is Use Case Task Group, which takes care of identification of potential use cases enabled by O-RAN, and alignment with other work groups. Next is Work Group 2, which defines the use cases and requirements related to non-RT-RIC, A1 interface and R1 interface. It defined the A1 interface between non-RT-RIC and the near RT-RIC to enable policy-based guidance and enrichment information of near RT-RIC, AIML learning, and deployment in RAN, and non-real-time optimization of RAN elements and resources. Work Group 2 also covers the definition of RAPs. Work Group 3. The focus of this Work Group 3 is to define an architecture based on near RT-RIC, which enables the near real-time control and optimization of RAN elements and resources, and actions over the E2 interface. This work group also talks about the near RT-RIC internal architecture and XApps. Work Group 4. The objective of this Work Group 4 is to deliver truly open front-haul interfaces, in which multi-vendor DU unit and the RU unit interoperability can be realized. Work Group 5. Work Group 5's main charter is to profile 3 GPP-specified higher-layer split interfaces to be truly interoperable between vendors, where it majorly focus on X2, F1, XN, E1 and W1 interfaces. It also does the gap analysis between 3 GPP specifications and fully operable multi-vendor specifications, and if needed, it identify and propose functions to be added to the 3 GPP specifications. Work Group 6. Work Group 6 takes care of cloudification and orchestration part of the O-RAN architecture. Here, cloudification means providing the flexibility of deploying multiple software implementations from different software vendors on a common CPU-based platform, which could be x86 or ARM-based implementation. Workgroup 6 Cloudification Charters is to identify use cases that will demonstrate the benefits of hardware and software decoupling of all ORAN elements and all deployment scenarios, and to develop requirements and reference designs for the cloud platform. Orchestration charter includes lifecycle management, fault, performance, configuration, across physical network functions and virtual network functions. So, overall, Workgroup 6 talks about service management and orchestration platform, OCloud, and the O2 interface between them. Workgroup 7. Workgroup 7 is called White Box Hardware Workgroup. As the name suggests, the objective of this workgroup is to specify and release a complete hardware reference design to foster a decoupled software and hardware platform. It includes the indoor picocell, outdoor microcell, outdoor macrocell, their energy-saving aspects, their deployment aspects, proof of concept hardware, test cases for verification and certification of all base station types, and usage scenarios. In order to summarize, the charter of Workgroup 7 is to specify and release complete hardware reference design of a high-performance, spectral and energy-efficient white box base stations for deployment scenarios as specified by service operators. Workgroup 8. Workgroup 8 is known as ORAN Stack Reference Design Working Group. The aim of this work group is to develop the software architecture, design, and release plan for the ORAN Central Unit and ORAN Distributed Unit. It is majorly the L1, L2 and L3 software stack, and their API definitions. Workgroup 9. Workgroup 9, which is X-Haul Transport Working Group, majorly focused on the transport domain, which means the transport equipment, physical media and control, protocols associated with the transport network underlying the assumed Ethernet interfaces. These transport equipments, utilized for front-haul, mid-haul and backhaul. The Workgroup 9 shall focus on specifying deployment architectures, requirements and solutions, identify gaps and proposals towards existing transport ecosystem. Workgroup 10 is known as Operation and Maintenance Workgroup. Workgroup 10 has full responsibility for the O1 interface-based OEM specifications for ORAN, including unified O1 interface operation and notification, and for creating a detailed OEM architecture. Workgroup 11. This workgroup focuses on security aspects of the Open RAN ecosystem. The WG11 is responsible for defining the requirements and specifying the architectures and protocols for security and privacy in ORAN systems. The workgroup shall specify security requirements, architectures, and frameworks in support of the open interfaces defined by other ORAN working groups. This includes security guidelines that span across the entire ORAN architecture. So, with this we cover the understanding of roles and responsibilities of each of the 11 technical working groups in the ORAN. Thanks for watching.